Hey Chem Kids, Campbell here. In our last video for chapter 14, we're going to talk about something with a strange name. It's called colligative properties. So I'm going to explain to you what they are, and then we're going to look at how do we figure out what's more effective at whatever these colligative property things are. So what are colligative properties? Well, colligative properties are properties of solutions that are controlled by the number of particles of solute that dissolve. Now, some things that are colligative properties are freezing point depression. So the lowering of the freezing point, like when they put salt down to lower the freezing point of ice, so our roads don't get slippery. Or vapor pressure reduction, and another one is boiling point elevation. Now, I said it's controlled by the number of particles of solute dissolved. So let's talk about that, because a solute, and we're talking about ionic compounds really, when they dissolve, they break into individual particles. And the more particles that they break into, the more effective they are at lowering the freezing point or raising the boiling point. So for example, here's some examples of different types of particles and what they dissolve into. So sugar, right? If you put sugar down to lower the freezing point of the ice, it's not very effective because it doesn't break into pieces. It's just one particle. But if I took table salt, sodium chloride, right, it would break into sodium and chlorine. So ionic compounds actually break into individual pieces. So that would give me two particles, one sodium and one chlorine. More effective, though, would be magnesium chloride, because when this dissolves, I get one magnesium and I get two chlorines, right? So that's 2 plus 1 is 3 particles, so more effective than sodium chloride, which is more effective than sugar. And aluminum chloride here, another ionic compound, so when it dissolves, it breaks into 1 piece of aluminum and 3 pieces of chlorine. Total of 4 particles. Wow, that must be really effective. Now, one thing I do want to point out is sugar. The reason why sugar doesn't break into particles is because it is bonded by non-polar bonds. Polar bonds. And those don't break into pieces. So these all stay together. When sugar dissolves, it stays as C6H12O6. Or I should say this is really glucose, not sucrose. Now, another thing that's really important that you know is that these solutes must be non-volatile. So that means that even though they dissolve, if I evaporate out the liquid, the solvent, the particles, that solute, will be back to being a solid. So let's talk about freezing point depression. What freezing point depression is the lowering of the freezing point of a solution. So I have a truck here that's spraying salt when it's snowing and we're afraid that it's going to freeze and get ice. So what happens is these solute molecules get in the way of the formation of the ice crystals. And so it lowers the freezing point of the water. That's why they spray airplane wings with de-icing fluid. That's why they put salt down on roads when it's going to freeze, because that will lower it. So it has to get even colder for that ice to freeze. Much safer. They should put more of that down at the intersection of Clayton and 109. Another colligative property is called vapor pressure reduction. Vapor pressure reduction, what happens is you slow the evaporation of the liquid, of the solvent. So what happens when you add this non-volatile solute, for example, to water, it keeps all the molecules tied down. So the water molecules, normally what happens is the water molecules on the surface are what evaporate. But if we put in maybe some sugar or some salt, now those take up some of the spaces at the surface and they can't evaporate, right? These are non-volatile, they don't evaporate. So that prevents some of that water from evaporating. So vapor pressure reduction really is like slowing down the evaporation of a liquid. The last one is boiling point elevation. So what boiling point actually is the temperature at which the vapor pressure equals the atmospheric pressure. So vapor pressure is the pressure in the liquid, and atmospheric pressure is the pressure pushing down from the atmosphere. And so if solutes reduce vapor pressure, that means it's got to be even higher to get to the atmospheric pressure. The temperature has to be even higher. So if we add a non-volatile solute, it raises the boiling point of a liquid like water. So you have to heat it up higher. The temperature has to be hotter in order for that solvent to boil. So in fact, one of the reasons why you add salt to water when you cook pasta is it makes it cook faster because the water temperature is hotter now when the water boils. And if it's hotter, it's going to cook faster. So colligative properties are properties that are controlled by dissolving non-volatile solutes. And the more particles that dissolve, the more effective they are. The more they raise the boiling point, the more they lower the freezing point, and the more they lower the vapor pressure. Let me ask you this. So it's been raining now, and the temperature is dropping, and you have to go to school. So in your house, you happen to have a large bag of glucose, sort of sugar, C6H12O6, and a large bag of table salt, sodium chloride. Which should you put on your driveway that would be most effective at preventing it from freezing so you can get to school? I know you're thinking, I don't want to put anything on it. But if we had to, right, this is what would happen, right? We put sugar, it only breaks into one particle. But if we put sodium chloride, it breaks its ionic, so it actually comes into pieces, and we get sodium and chlorine, 2 particles. So if I really got to get to school and I only have those 2 choices, I'm going to put the sodium chloride down. So if you said sodium chloride, you are on the money. See you at school.